right. Hey, I get to be in the video for this one. I'm not a huge fan of being on camera, but here we go. Okay, we've been talking volume. So we're going to do a little bit of looking at volume and comparing volume. We've already found the volume of this guy. Okay, here we have a nice square prism. Its base is a square. The sides are all rectangles. Well, in this case, they're actually all squares as well. So this is a square prism. Sometimes we call it a cube. Okay, so we have that square prism. And we know how to find the volume of this, right? We take the area of the base. So look at that base, find the area of that, and multiply by the height. Okay, so we're now going to look at what about this. Okay, this is also have a square for a base, square base, but this no longer has two bases. It comes up to a point. So this is a right square pyramid. And we want to compare the volumes. So first thing I want you to do is I want you to think about how do you think they compare, the volume. Again, that's the amount that the inside will hold. So how does the volume of this compare to the volume of this? Okay, which one's bigger? Okay, give it a thought. Okay, you're right if you said the volume of the prism is going to be greater. Okay, the pyramid's going to have a smaller volume. Okay, because it's smaller, right? There's not as much space inside. Okay, so if you notice, these two shapes have the exact same base. Exact same base. Okay, they're the same. They're also the exact same height. Okay, total height from bottom of table up, total height. So now we're going to compare the volumes. And I'm going to do that by actually filling them and seeing. Okay, so I want you to first jot down, just grab a piece of paper and jot down, how many of these, we already agreed that this volume's bigger. How many of these, the volume of our pyramid, will it take to fill the volume of our prism? Okay, so go ahead and let's jot that down. And then we're going to see. Okay, so jot it down. Give you a hint, it's less than 10. All right, so let's go. So I'm going to go ahead and I'm going to fill this guy. So I'm going to, just to prevent some spills here. Okay, so I'm going to fill my pyramid all the way to the top with water. Tippy tippy top. And let's see. Let's go ahead and let's pour it in my prism. I lost a little bit, not much there. Okay, so there we go. Got about that much water. I don't know, maybe about half. Do we think it's going to take 2 to fill it? So let's go ahead, let's try it again. Let's see, maybe it'll take it even 2. Let's go ahead, let's fill it again. All the way to the tippy top. And let's fill it. Let's see. 2? Nope. It's going to take more than 2. Okay, so if you notice there, it's going to take more than 2. Let's go ahead, let's do one more. Even 3? Or do we think it's not even going to be 3? It's going to be less than a third one? Okay, let's try it. Ready? This could be a big mess. Let's see. There's water. 3. Oh, perfect. Okay, I lost a little bit around the edge, but if you notice, it's exactly 3. So it takes 3 pyramids to equal the volume of 1 prism. So that tells me that the volume of this pyramid is 1/3 the volume of that prism. So what's nice is we can use our equation for the volume of a prism, like this guy, and cut it into 1/3 to find the volume of the corresponding pyramid. Okay? And that works for any type of prism and pyramid. If I was to repeat, again here we have a triangular prism, okay? A triangular pyramid, exact same base. Okay, their bases are exactly the same, and the exact same height. Okay, but again, it's going to take 3 of these. We'll go ahead and I'll show you just to make sure. It's going to take 3. There's 1. And 2. And 1 more. And 3. Ah, okay, I spilled over a little bit. That's going to take 3. Again, 3. So again, the volume of a pyramid is 1/3 the volume of the corresponding